Hello everyone. In this video, I will try to cover the complete Internet Protocol version 4, a complete video training from beginner to advanced level, including subnetting, VLSM, CIDR. Not up to only this, I will cover private and public IP and APIPA. Okay. So if we look very fast here, look at first definition, structure, conversion decimal to binary, then binary to decimal conversion, everything we will cover here. I'm showing you very fast, including all the classes and everything I will cover. So please watch the video completely. I ensure you, after watching this video, you need not to go to any other channel or any other training for IP. Why I'm doing so? Because either a network administrator, server administrator, or system administrator, everyone should have the thorough knowledge of IP. And in my last video that I was recording on AWS VPC, that time also identify that I should repeat this topic. Otherwise, I already have a complete IP version 4 video series there on the my YouTube channel. But rather than watching the video series, now you can take the complete knowledge of IP in a single video. So please have patience, watch the video completely. After this, you need not, I think you will not get any question to ask me or to anyone. I will provide you a complete thorough knowledge in this. Okay, so let's start with the IP. So IP stand for Internet Protocol. The full form of IP term is Internet Protocol. It is a logical address assigned to every device in the network to identify the particular device in a network. Without having a proper IP, no device can communicate over the network. There are two types of addressing in the networking. One is logical address that I am showing you, and one is the physical address. Okay. So IP is a logical address, means can be changed, but every device in the networking have a physical address also, that is the MAC address. So I will not go in depth for the MAC. Right now we have to discuss about the logical address that can be changed with time to time. But without having a proper logical address, it's not possible to communicate over the network. Okay. So this is the structure like this. You need to configure on each device, like I show you my computer also. Network and sharing center, adapter setting here. I'm showing again properties. If you and you check IP version 4, here you can see we need to configure it. One option, obtain the IP address automatically, that is via DHCP server you need to configure. But manually, if you need to configure, you have to configure IP address, subnet mask, default gateway and DNS, so that your device will be able to communicate over the network or internet. Without having these settings, device cannot communicate over the internet. So just only for your reference that I shows you. Okay. So this is the IP address. So without having this IP address as well as subnet mask as well as gateway, your device will not be able to communicate over the internet. Okay, so you should have all these things. So we have to focus on these two things right now, IP address and subnet. I will discuss with you about the IP address and subnet mask in very detail in upcoming slides. So actual definition you can say is a 32-bit address. It is a 32-bit address, logical address, divided into 4 octets separated by a decimal. Why it's bits here? Logical address or IP address is designed in binary number system, not in the decimal number system. I was showing you previously here this is a decimal number system, but actually IP is designed in binary number system. Hope you are familiar with bits and bytes term. So 32-bit divided into 4 octet separated by a decimal. Now what is this octet word? I don't want to leave a single word that make you confused. Octet is basically a collection of 8 bits. In normal it is called byte. Collection of 8 bits is 1 byte. But here in case of IP it is called 1 octet. Collection of 8 bit called 1 octet. Collection of 8 bit called 1 octet. So let's check the actual structure of IP. This is the actual structure of IP. What I say is 8 bit separated by decimal, again 8 bit, then again separated by decimal, then again 8 bit separated by decimal, and then again 8. So 8 plus 8 plus 8 plus 8, 32 bit. Same for the subnet mask. 32 bit, 8 bit separated by decimal, 8 bit separated by decimal, 8 bit separated by decimal. So collection of 32 bit. Now before proceeding, you must be familiar how we can convert decimal to binary and binary to decimal number system. If you don't have the thorough knowledge of this conversion, again become difficult for you when we go for the advanced topic of subnetting and VLSM or CIDR. So I'm not take much time because I expect that you all know this, but still for easiness I'm just taking a few examples here. Like I have taken decimal number system 92 and I want its binary number. So what I do? I divide by 2. Divided by 2. Then 96 remainder 0. 48 remainder 0. 24 remainder 0 divided by 2. 12 remainder 0 divided by 2 6 divided by 2 3, again 3 divided by 2 1 and remainder 1. So now what I will like this way from down upside. So 192 the decimal number system equivalent to this binary number system. Clear? So very easy, nothing complicated, just practice some few things, you will really clear to you. If I go with the reversal process of this, look here. This was the 192 binary. So what we do here, writing is little poor. This is a 0 position, first position, second position, third position, fourth position, fifth position, sixth position and seventh position. 2 raised to power 0, 1, 2 raised to power 1, 2, 2 raised to power 2, 4, 2 raised to power 3, 8, 2 raised to power 4, 16, 2 raised to power 5, 32, 2 raised to power 64 and 2 raised to power 128. Okay, so 128 multiply by 1, it becomes 128. 64 divided by 1 becomes 64. Remain all are zeros, it becomes 0. So when we add, we get 192 back. So in this way, we can do decimal to binary and binary to decimal conversion. Okay, same process here. 160 is a decimal number system, keep dividing by 2. Oh, what happened? Look here. 10101000. It will be the equivalent to 68. 10101000. Start from this side to this side. Same is the reversal process. 10101000. 2 raised to power 0, 1, 2, 3, 4, 5 up to 128, and it will be 168. I take it little fast, but still I think it's clear to you, just to revise you how we can do the decimal to binary and binary to decimal conversion. Comfortable up to this? Please do more practice for it. It will be very helpful for you in the upcoming slides to understand about the subnetting, even the structure of IP, even the class of IP. It is must for you to learn this thing. That's why I include here in the IP training. Okay. Suppose we have all ones. We have one IP in binary that is all 1. What can be the maximum value? 128, 64, 16, 8421, 255 means 8-bit value. 1 octet maximum value can be up to 255. So as I'm repeating, it's a 32-bit and divided into 4 octet. So minimum value can be 0 and maximum can be 1. What does it mean? What can be the minimum IP? All zeros. All zeros in a IP. And what can be the maximum? 1, 1, 1, 1, 1, 1. All 1 means all 32 1. So what can be the minimum to maximum value? When we convert it into the decimal number system for our easiness, what can be the maximum to minimum value? So I was discussing that what can be the minimum and maximum value of IP. So you can see here in decimal number system, the minimum IP can be 0.0.0.0 to 255.255.255.255. So this can be the minimum to maximum IP value. Maximum to minimum. Clear about the structure of IP? 32-bit address divided into 4 octet. Each octet have 8 bit. The minimum value can be 0.000, all zeros, and maximum can be all 1. When we convert this binary number system, I told you it's very important to understand about the decimal and binary number system conversion. So when we convert it into the decimal number system, it becomes 0.0.0.0 to 255.255.255.255. It is the structure, basic structure of IP. So please, if still have any doubt in decimal to binary and binary to decimal number system, please go back and watch the video again and practice that. Okay. Okay, next and most important also about the different class of IP. Class basically has been identified on the first octet of an IP. There are 4 octet. If you remember, there are 4 octet in an IP. Class is always identified on the base of first octet. What is the value of first octet? On the base of that, we define IP class. So in last video, last PPT presentation, perhaps you remember, minimum to maximum value can be 0 to 0.0.0.0.0 to 255.255.255.255. And if we discuss about the class, this first octet of any IP identify the class. We don't care about all 3 octet. Class is always identified based on the first octet. Let's come to the classes. If first octet of an IP start with 0 to 120, 1 to 126. If any IP first octet start with 1 to 126, that is the A class IP. If any of the first octet starting with 128 to 191 comes under the B class. If any IP starting with 192 to 223 C class, any IP starting with 224 to 239 is a D class, any IP between first octet 240 to 255 is the E class. Always keep it in mind. By looking at the first octet, you can identify with which class, either A class, B class, C class, D class or E class, this IP belongs. What we have seen, that is a decimal format. So make us confused. Let's come back here. Why it end with 126? It can be 125 or 130. Easy to remember. It can be 230 or 225. It can be 190. Why it stop at 192? Why at up to 224 to 239? It is little difficult to remember. But actual reason behind this is again something different. That is the decimal number format that we are discussing. The Y class A end at 126. It can be 125 or 30. Why B class end at 191? It can be 90. Easy to remember. Why C class end at 224? It can be either 20 or 25. Because this is a decimal number system. Actual reason behind this is IP class has been designed in binary, not in decimal number system. See, if I show you any IP in binary number system, if I show you any IP in binary number system and I ask you with which class this IP belongs, So by looking at the first octet, you can identify if first bit of first octet is 0, you can say it's a A class. If first 2 bit on any IP in binary number system is 10, it is a B class. And C class IP series always start with 110. You can practice it, you can check it. Any number you convert to the binary between 1 to 126 always end with 0. Any number in between, so you can do a lot of practice here. Any number you take and convert it to the binary, it always come with 10. Remain what is the bit, don't care. Any IP in between these two, either take 193, 200, 221 if you take, its first 3 bit will be 110. So by simply looking at the first octet bits, you can identify, rather than converting into the decimal, by looking at the first octet, you can identify, yeah, it's a A class, it's a B class, or it's a C class. Got the reason? What is my purpose to discuss all these things? To make you very much familiar with the binary number system also. So clear up to this? When we was checking about the class, so A class ended 126 and B class start with 128. Please keep your copy and pen ready. Keep your copy and pen ready and check. 127 is not there. What is the use of that? Where the IP 127 series go? What is the use of that? 127 is used for self-test of machine and also known as loop back IP. What is the loop back IP? To check whether my NIC LAN card is able to communicate with your operating system, driver is properly not installed or installed properly. So we use for that. That is a different topic. We will discuss somewhere else. So 127 is known as the loopback IP series. So when we talk about an IP, like I'm taking one IP here. I'm taking one IP here. So say 192.168.1.10. Okay, leave it 192.168.10.10. Take any IP, for example. Like, how can I identify which portion of an IP belongs to host part? Means it is a complete network and this is the host identification on a network. 100 of machine in a network, like a city, and then house numbers. It is the, how can you identify that it is a complete network and it is a device inside that network? How we can identify? So whenever we take any IP, out of 32 bit, some bit identify a particular network, like a city name or a state name or a country name. Same like any telephone number, like for India, it always start with +91 hyphen any number here. So this particular identify the India state, India country, and remain some portion about ISP or telephone service provider, and then some particular number identify a particular mobile set. In the same way, in an IP, some portion identify a particular network and some portion of the bits identify a particular device. Okay, so how we identify that which portion of IP belongs to network portion and which portion belongs to host part. So each IP consists of two parts. Some bits of an IP are network bits and some are host bits. How we identify that? That we can identify with the help of subnet mask. Subnet mask. If you have seen the structure there, I've shown you. First is the IP address and next is the subnet mask. So how we can identify? These are the default subnet mask for each class. One thing I want to more add here, perhaps let me check. Okay, I will let it know later. So these are the default subnet mask. For A class, the default subnet mask is 255.0.0.0. B class, first 2 octet belong to 255 means 111. If you convert it into the binary, I'm again and again saying everything 1 or 0 means binary number system. So if you say 255 and convert it into the binary, it will be 111111 8 times. So in a subnet mask, one portion represents the network. Like here, first octet is network portion, remain all are the host. First 2 octet is the network portion, remain 2 are the host part. And in C class, default subnet mask is 255.255.255.0. Means first 3 octet represents network portion and last octet, here is the single zero in decimal number system, but if you convert it to the binary, here will be 8 zeros represent host portion. Let's see some examples. So can you identify? I have told you, by looking at the first octet here, you can identify a class. Which class is this? It is the C class IP. First 3 digit is 110. Please watch each and every slide carefully. I have shown you. If first octet first bit is 0, that is the A class. If first 2 bit is 10, then B class. If first 3 octet 3 bit is 110, it is the C class. So it is a C class IP. So as I shown you in a previous slide, C class default subnet mask is 255.255.255.0, means all ones. So C class IP, so it will be its default subnet mask. So now I think you understand the importance of binary to understand the IP addresses. If the default gateway, we don't care for default gateway right now. I show you practically also. Come here. If I configure some IP manually here, change it after setting, properties, And if I try to configure static IP here, suppose 1 to 126 is the A class IP. So if I say 10.0.0, give any, I don't care about the host. And when we click on the subnet mask, it automatically take A class default subnet mask, that is at 255.0.0.0 that I was showing you here. A class default subnet mask is this one. So if I come here and click on the subnet, but it's automatically take 255.0.0.0. For B class comes 127 to 191. Suppose I take here 190. B class IP, and when we click on the subnet mask, look here, it is taking B class default subnet mask. And if I take here C class IP, means 192 to 223. I take here 192. I don't care about the remainder because the host portion. For each machine, for each device, it will be different, but it should be same. Look here, in the C class, it automatically take this C class default subnet mask. Hope clear? So this is about the subnet mask. So by looking at the subnet mask, and when we compare it with the IP up to here, first 3 octet will be the network bit, and this is the host bit to identify a particular host in a network. This is one network and this is the host. It will remain same in the same network. This portion remains same in the same network, and this always varies for one device to another device. It will be changed. Suppose one device giving 1010, next device go to 132, then next 3. As much as device we have to give a different host bits. And always keep it in mind, subnet mask is always contiguous, can never be discontiguous. What does it mean? Like look here, IP is like this, 110000101010, but subnet mask can never be like that. If one network portion is going, it will always remain contiguous. It can never be like this, like 10 here, 10 here. It can never be possible. Subnet mask is always contiguous. Keep it in mind. Can never be discontiguous. Okay. So if we take the example of C class, please try to understand it very carefully. I'm taking this IP series 192 because C class start with 192, 168, 1. Default subnet mask is this one. So what I want to show you here, look. So now see very carefully. First IP is known as network IP. Please take the notes. Then it is the subnet mask that by default, or later we do the subnetting, that time we change it. Subnet mask. Then what? First valid IP. What does it mean, first valid IP? The IP that we can assign to the devices. So it keeps changing. It will not change in the same network. 192.168.1 will remain the same. It keeps changing. 2, 3, 4, 5, 6, 7, 8, 9 and can go up to 254. It is known as last valid IP. And it is the broadcast IP. It is known as broadcast IP. Remain all. These are the valid IP range. First IP is known as the network IP and last IP of the series, because now if you see 1, 1, 2, 3, 4, 5, 6, 7, 8, all the host bit becomes saturated now. We don't have more space here to put more devices because valid IP is up to 255, 254. And 255 is known as the broadcast IP. And first is the network IP. We cannot use this IP and we cannot use this IP. We cannot assign these IPs on a machine. Because if we go very depth, this IP is used by the routers to communicate in different networks. And this IP is reserved for broadcasting in a whole network. So this is the valid IP range. Only we are doing the change in host bit of a subnet mask side by comparing it that this portion is the network portion. It will remain same. You can see here up to here it is same. From one device to another device, this host bit keep changing. 1, 2, 3, 4, 5, 6, 7, go 100, then 100, 1, 2, 3 and go up to 254. And last broadcast type is 255. Clear? See more example perhaps. We talk about the B class IP series. I'm trying to give you very much examples so that concept should be clear to you. Now I'm taking B class IP 172.168.0.0. First valid IP 172.168.0.1. We always start from this side to this side in a host, like in a electronic watch, na? Like in electronic watch, you see first hours, then minutes, then second. Suppose this is a timing. So once this side becomes saturated, when it becomes 59, 10.59, it can go up to 59. If you remember now seconds, then it become 1.0.0. Again it start 1, 2, 3, 4, 5, go up to 59. In the same way, we start from this side and go up to this side. 1, then it goes 2, 3, 4, 5, 6, 7, go up to 255. But don't worry, still host bits are empty in third octet. Again the counting start 1.0. This is also valid IP and this is also valid IP. Till a single bit is off in the host portion, that is a valid IP. Or single bit is off or single bit is on and off, 1 on, 0 off. So now it is network ID, network IP. Okay, it is subnet mask. It is first valid IP. It is the last valid IP of the in between. I will calculate also. We will calculate also that how many IP exist here, because 16 bit is empty here. 8 bit plus 8 bit. 16 bit is empty here. So it will be its I think goes problem. Last valid IP. And it will be broadcast IP. Where it's going. It will be the broadcast IP. It is the I'm writing again. We are going little slow. Video will go very lengthy. Network IP. Otherwise, we'll complete in some another video also. It is the subnet mask. It is the first valid IP. So it was a B class structure. Always keep in mind, if single bit is off, here 8 bit here off and 7 bit here off. That's why 0.1. Always calculate on the base of this 0, 0, 0, 0, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7 and 8. It is the binary conversion of this IP. Means single bit is on, it's a valid IP. Here single bit is off. Means I'm changing the color 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. If single bit is off, that is also valid IP. A single bit is on, that is valid also. But when all host bit is off, that is the network ID, and when all bit is on, that is the broadcast IP. I think now it's clear to you. Let's see, we have the E-class example also. The network ID, default subnet mask, first valid IP will be 10.0.0.1. Last valid IP will be, write me in the comment, what will be the last valid IP? 10.255.255.254. Compare it here. This for sure. With the default subnet mask. Okay. And what is the broadcast IP? It will be the broadcast IP when all the host bit become saturated. Saturated means all become one. There is no more space for the host machines. So here, according to this subnet mask, this 16 bit is the host bit. Again same, start from this side. When this become 255, start 1 from here, again counting start here, then again it become 255, then again 0, 0, 0 counting start, and keep counting like a electronic watch. Our minute, second. First saturate, second become saturated, minute increment. Again second saturate, then minute increment. When minute and second will become 59.59, then hours become incremented by 1 and counting start again here. So this is the IP. I've taken the example of C class, I've shown you the example of B class, I've shown you the example of A class. Most important question that I have shown in C class, B class, A class. Here only 1 octet means 8-bit. Default subnet mask is 255.255.200 for C class, and for B class default subnet mask is 255.255.0.0, and for A class 255.0.0.0 means 3 octet 24 bits are available for the host. How we calculate how many IP can exist? How many IP can exist in C class? We have to set up a small network. We have to set up a big network. Then how we calculate that? Each class of IP has a fixed number of IP. We can find out the number of IP can exist in an IP series by using the formula. Always keep it in mind this formula. 2 raised to power x total IP. What is the x? X is the number of 0 in a subnet mask. Means number of 0. First look the last formula also. 2 raised to power x minus 2 is the valid IP. With the help of a single formula, we can calculate how many IP can exist in a class. We have to do the setup of 200 machines only, 200 devices only, or we have to set up a network with 10,000, 50,000, 10 millions of machines, devices. So which IP class we choose? We choose A class, we choose B class, we choose C class. So in a C class, the default subnet mask is 255.255.255.0. If we convert to the binary, so it is a 8 zeros available. So the formula was 2 raised to power x. X was number of 0 in a subnet mask. Clear? So 80, so 2 raised to power 8, 256. So total IP can be 256. And I have told you 2 IPs are reserved there. One is the first one and one is the last one. First one is the network IP and last one is the broadcast IP. So that 2 IP cannot be used here. One is the network identification, one is for the broadcasting. So we do -2 here. It becomes 254 valid IP. So in C class, maximum we can connect 254 devices. In B class, it's 255.255.0.0 means 8-bit, 8-bit. So 2 raised to power 16. Total IP 65,536. And -2 again same here, 65,534. Device we can connect in a B class. And in A class, Subnet mask is 255.0.0.0 means 8, 8, 8, 24 bit. So 2 raised to power 24, I think it's going to be billions. 16 billion, 77 million, or 1 billion, 67 million, 77,216 device can be total IP, but minus 2 is the valid IP. So big network we can create, but the problem here is one network ID and one broadcast IP for billions of devices. Always keep in mind this formula when we have to calculate how many devices we can connect in a IP series. Okay. So that I mentioned here, when all the host bit of an IP is 0, that is known as network IP, and when all the host bit of IP is 1, that is known as the broadcast IP. And both network IP and broadcast IP cannot be configured on any device. Okay, so hope till yet every point regarding the basics of IP class, role of subnet mask, network bit, everything should be clear to you. If any doubt, please watch the video again. Okay, I have discussed each and every point here, from very basic to advanced of IP structure, and everything I have discussed. Even I have given the example of all the IP classes. What is a valid range? What is network ID? What is broadcast IP? I have mentioned everything. So let's come to the next topic of IP is the subnetting. What is subnetting? Why we do and how we do it? Okay. So first thing, why we do the subnetting? The main purpose of the subnetting is to break a big broadcast domain into a small subnets to reduce the broadcast domain. As you see here, just I want to show here. Like for this all billions of devices coming into this network, broadcast IP is 1. If any broadcast go, it will go to the entire machines, billions and billions of machines it goes. Or whatever the device is connected, it will impact the all devices in the network. So it reduces the network performance. It reduces network performance because broadcast is the biggest devil in the network that reduces the network performance by consuming the bandwidth and unnecessary utilization of network resources. Because when any broadcast generated in your network, it consumes a lot of bandwidth, unnecessary utilization of network resources. Okay, now. So as a network administrator, my main aim is to reduce that broadcast. For that purpose, we do subnetting. Subnetting means to break a big network into small networks. Clear? This is the prime purpose of subnetting, to break big broadcast domain. So how we can do that? How we can do that? We will do it with example. Let's start with the C class. I told you I will give a lot of examples to make you everything clear as much as possible for me through video. I have taken this C class IP series. This is the one broadcast domain. So network ID, valid IP range, I have mentioned you, I have explained you that, and it is the broadcast IP. For the entire network of 192.168.1.0 network, broadcast domain is 1. So how we can do that? I want, rather than becoming single broadcast domain, I want to divide it into two broadcast domain. Suppose I have two departments in my company. One is the marketing, one is the financial, take any. So what I want, rather than using single broadcast domain or single plain IP series, I want this broadcast remain here and broadcast generated here remain here. This broadcast will not impact another network. This will not impact this side. So my first example, I will take a lot of examples. It will take a lot of time, but have patience, watch it, you learn everything here. Everything will be clear to you. I will go step by step to make you clear. To break this C class IP in my last example into two subnets. This is the default, or sorry, you can say network ID, and this is one subnet mask. So how we can do this? Network IP and one is broadcast IP. Here we require two subnet, as I discussed with you. For that purpose, I have to use another formula, 2 raised to power y, number of subnet required. Y, what is the y? Number of bits to be borrowed from host side to network side in a subnet mask. IP remains same, only subnet mask we change. So we have to remember many things that we have discussed previously. Means in this case we need to borrow. For this case we require two subnets. Please watch carefully. We require two subnets, and to fulfill this requirement, formula is 2 raised to power y. Means when if we put the value of 1 here, then it becomes 2. Means we need to borrow 1 bit. We need to borrow 1 bit from host to network side in a subnet mask. This is a default subnet if you convert it to the binary. But according to this condition, required two subnets, we need to borrow 1 bit. I am repeating again and again. Listen carefully. What we do, we just change. This is the host bit. 0 means host bit, 1 means network bit. We do the change here only. Why we do the change here only? Because I told you subnet mask is always contiguous, can never be discontiguous. So borrow 1 bit, the new subnet mask will be this. We borrow 1 bit from host to network side. If it is 0, it is the host side. If it become 1, then it is network bit. Now entire scene has been changed. Either IP series remains the same, but their subnet mask has been changed, and by changing the subnet mask, new subnet mask will be, that's all, converted to the binary to decimal number system. So new subnet mask that we have to assign will be 255.255.255.128. And where we do the changes, like in 4th octet, we do the changes, is known as interesting octet. So next is block size. What will be the block size of two subnets? In two block in subnet we create. When we divide each network, which is a big network, into small subnets, each subnet or block will get a specific number IP. For example, we have a big room here, and first it is have some length, have more space. But if we divide this room into two parts with the help of a wall, then this particular area has some specific size, and this particular area will also have some specific size. The same way, when we divide a big network into small subnetworks, each total IP in the C class is 256, if you remember. Okay, so here also each block will get some specific IP. So block size, what will be the block size? Total IP in a block value vary from 0 to 255 maximum in a octet. So how many total? 256 value. So block size will be 256 minus the value of interesting octet in a subnet mask. And interesting octet is the octet where change takes place in a subnet mask. So in this case, in this subnet mask, change come here in 4th octet, so it will be my interesting octet. So block size will be 256 minus the value of interesting octet. So block size 256 minus the value of interesting octet, that is a 128. So block size will be 128. Means each subnet or block will have 120 total IP. I want to show you one more thing. Now here also you can see in the subnet mask how many host bit? 7. If you remember the previous formula of 2 raised to power x, how many total IP can be there? 2 raised to power 7 is also 128. 2 raised to power 128 is also 128. So we will get 2 blocks of 128. This will be the first block, means it will be the network ID, first valid IP, it will be the last valid IP, and it will be the broadcast IP of this block. Okay, it is a valid IP range in this block, and it will be the network ID. But hardly you have to keep it in mind when configuring these IPs on any device. Subnet mask should be that one that we calculate in our previous slide. Second block, start with it end with 127 broadcast, 128, First valid IP will be 129, goes up to 254 last valid IP, and broadcast will be 255. Now each block have its own broadcast IP. This broadcast IP, network ID is this one, network ID is this one, and broadcast will be this one, and this will be the valid IP range. Clear? Now we have break the broadcast domain, but again I'm mentioning you have to mention the broadcasts that we calculated in our previous video, previous slide. You must have to mention this subnet mask now, not default subnet mask. Simple. Just I will go with one more example. In this case, we generate 4 subnets. Same process, nothing special. Same IP series have taken 2 raised to power I number of subnet required. Y number of bits to be borrowed from host to network side in a subnet mask. So what value I should put here to get the first subnet? 2 raised to power 2. I think that is 4. Means we have to borrow 2 bits from network host to network side. So default subnet mask is this one in binary form, but we borrow 2 bits. What will be the new subnet mask? 192, 255, 255, 255, 192. Same process, nothing more. So we have to calculate block size with the help of interesting octet. So 256 minus the value of interesting octet 192, block size will be 64. Means each block will have total 64 IP. Look here. So look here, 1, 2, so now we have the 4 blocks. Network ID, network ID, network ID, network ID. Valid IP range, valid IP range, valid IP range, valid IP range. Broadcast, broadcast, broadcast and broadcast. But again same thing, you have to hardly mention here the subnet mask of with each IP. If you do something wrong here when you are configuring the IP on the devices, then everything will be messed up. For all the subnets you have to mention the same subnet mask. Little bit interesting, little bit confusing, do have to lot of practice. Right now we have configured 4 subnet mask. You try for 8, 16, 32, as much as you want. This is the C class example. Let's check fastly on the B class also. In B class IP 172 means B class. We need 2 subnets. Process is same. So default subnet mask is this, means this is the network portion and this is the host portion. Process is same, formula is same, everything is same. 2 subnet, 2 raised to power y, number of bits to be borrowed from host to network side in a subnet mask. So we need to borrow 1 bit. Okay. So default, but when we borrow 1 bit, again same thing. Subnet mask is always contagious. means we have to borrow the bit from this to this side, not randomly choose any bit here, choose randomly bit here, not possible. Subnet mask is always contiguous. So new subnet mask 255.255.128.0. Same again, have to calculate block size. 256 minus 128 means value of interesting octet. You're getting why I'm taking 256, because in a range here in each octet maximum value can be 255. So 255 0 to 256 counting become 256 IPs, but 2 raised to power 8 is also 256. So out of 256 128 goes, block size will be 128. So look here, now third octet we have to do the variation in third octet here. That is why interesting octet where subnet mask change take place. All means 8 plus 7 bit here with subnet mask is the host bit, and 6, 8, 8 and 1, 17 bit is the network bit. Come back and check again. Here you can check, means 255 is the same, and 1 bit we borrow from host to network side. Okay, so all the variations come in third octet. This 128 impact your third octet, not only fourth octet. So look here, variation come here of 0 to 127 is 128, and here also 128 to 250 variations coming here. This value go 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 up to 255. Again it become 129. Again value go to 255, become 130. It keep going, and last valid IP will be this, and broadcast IP will be this one. Here also this value comes, because next 128 start in this series now, in this block now, goes into this block. So 127 will be last IP. Confusing? No problem. Try one more. Perhaps we have same for subnet. You have to do a lot of practice. Because in video I cannot make it more lengthy by taking more examples. So same process here. Now we require 4 subnets. We require 2 bit to borrow. We borrow 2 bits. So new subnet mask will be 192. That variation comes in the third octet. Variation come in third octet. Subnet mask is contiguous, I am always saying, so it remains contiguous. Again calculate the block size. 256 minus 192. Block size is 64. You can see here this variation is coming here 0 to 63, 64. 64 to 127, 64. 128 to 191, 64, and 192 to 255, 64. As I told you na ki if single bit is on, that is also valid IP. If single bit is off, that is also valid IP. Means IP coming in between this is valid IP, valid IP, valid IP, and valid IP. Network ID, network ID, network ID, network ID. Broadcast, 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 and broadcast. So now each block have its own network ID, each block have its own broadcast IP. Only you have to take the precaution for assigning the subnet mask. Subnet mask will be for each block. The subnet mask remains same 255.255.255.192. If you do some wrong here, entire network mesh up. Machine goes out of that network. You assign the wrong IP here, the wrong subnet mask here. So this is the B class. Maybe we have some example of 512 subnet. It goes long. Let's see very fast. 512 subnets. So how many bit we require to borrow? 2 raised to power 9 bit we have to borrow. In 9 bit we have to borrow. Check the default subnet mask. So how we can borrow 9 bits? 8 bit in third octet and 1 bit in fourth octet. So it will be my new subnet mask. It will be my new subnet mask in decimal form. Now we have to consider two interesting octets. Third block octet size and fourth block octet size. Now simultaneously we have to take two block size for third octet and for fourth octet, because variation comes in 2 octets. So in case of third, the value will be 1, because third octet decimal value is 255 there, so block size is 1, and fourth octet value is 128. Now look here, first we do the variation in fourth octet. Network ID, broadcast IP, and variation comes here. Sorry, valid IP will be this range, because fourth octet block size is 128. Again, start with 127, finish here 128. Now it is the network ID, valid IP range, and broadcast IP. But now look, your fourth octet becomes saturated here. So third size block size is 1. Look here, variation comes here. Again get repeated, 127, 1.128, and go 125. It keep going up to 5,000. I cannot show you all the subnets. If you get 2.1, 126, 127, next block will be 2.128. Sorry, it's a 1, not 1119. There is a 129, 128 and 129, 254, 255. Again it becomes saturated, it becomes 3 in our next block. So it keep going. One time come when it become this one. Okay. 126, there is a 1. Sorry, by mistake I written this one. There is a 1. 127, 128 start. Here I have done the mistake. It's 1, not 129, 254, and 255 will be the last block. 172.68.75.128 is the last block. Network ID, this is the last block. Valid IP range, and it will be broadcast IP. I hope I have taken 3 examples of B class. It should be clear to you, remain up to you, you do the practice or not. But you will not find any video on YouTube in so much detail with so many examples. Subnetting of class A. Same thing, nothing is different, only you have to take care for the subnet mask. In C class, these are the host bits and these are the network bits. So you have to do the changes in last 3 octet. We require 2 subnet. We need to borrow 1 bit according to the formula. Default subnet mask. After borrowing 1 bit, this become new subnet mask will be 255.128.0.0. So means now we have to take extreme care on second octet. That is my interesting octet, single interesting octet. Same, calculate the block size 256 minus the value of interesting octet. I'm going a little faster because I have given you so many examples. So block size will be 128, very simple. Now take care here. Network ID, valid IP range, first valid IP, last valid IP. We saturate all the points here. It keep going like 255 comes here. Then it become 1.0. Again 255 come here. Then it become 2. It keep going. Then point come 0.255.255. Then 1 become here, and again continue. This is the first block with this broadcast type. Here is the changes come in here. So look here, 128. Changes start in 4th octet, keep changing up to 4th, 3rd, 2nd, and this will be the broadcast type. Hope clear? Same process for the source subnet. I don't want to take more time. We need to borrow 2 bit. We borrow 2 bit here in the second octet. So new subnet mask will be this one. Again we have to calculate the block size. Okay. So block size will be 64. Look here. Change is coming in second octet. Remain, we have to saturate all the host IPs. It keep changing. Look. Valid IP range, network ID, broadcast IP. Valid IP range, network IP and broadcast IP. Network IP, broadcast IP, valid IP range, and here also network IP, broadcast IP and valid IP range. So in this way we do the subnetting. I don't think right now you have any doubt. For subnetting, I don't want to do more. So in this way you can check the video in slow. I'm showing you all the thing. Here the variation coming in 3rd and 4th block size, 2nd and 3rd block size. Look here. So watch the video carefully. You have seen everything. So one more thing I want to add here. Sorry, good. Subnetting. At the end I will type a note for you. what I want to say, subnetting is also known as FLSM, means fixed length subnet mask. Means length is fixed for entire subnet. All the blocks that we generate here have a fixed length, fixed block size. It also creates a problem for me. How many IP we are getting here? Okay. So maybe in some departments I require only 10 IP. And in some department maybe I require millions of IP. But the block we are getting here is only of 128. So if we are getting the block of 128, then in case of IP requirement 10, lot of IP wastage. But if we require more IP for more than 128, then how we manage that thing? By doing the routing with the help of a router, that we can do, but still it will be problematic for me. It's a big wastage of IP because it's a fixed length subnet mask for the all blocks that we generate here. So next is the variable length subnet mask. Okay, so to sort out that problem, we use the VLSM, variable length subnet mask. So how we do the VLSM? I want to show directly. Sorry. This one. Sorry for the whole waste. So consider a traditional C address space like 192.168.1.0 in an organization with department. One department have 14 hosts, second department have 30 hosts, third department can have 60 hosts, 120 hosts. Means different department have a different strength. If we do the FLSM, means subnetting, with all 4 subnet block will have equal IP. Maybe in some condition it is a wastage of IP, and in some case IP is not fulfilling the requirement, like in case of 14, and with the FLSM we have fixed 64 IP in each block. In case of 14 it is a wastage, 30 wastage, 60 okay, it can be adjusted. But with 4 hosts, 4 department, we require 120 hosts, not fulfilling my requirement. Got the point? So what we can do for that? For that we use the VLSM. Means we can design the subnet with we can design the subnet with or block according to IP required in each department according to the company hierarchy. line is going wrong because now I'm tired. It's going to be around 1 hour 45 minutes to keep speaking. So each block will have different subnet mask depending on the requirement. In FLSM, the subnet mask was fixed for all the blocks, but here in this case, we design the different subnet mask for different blocks according to the requirement. Means subnet mask length will not be fixed for each block. Correct? In FLSM, subnet mask length was fixed. That's why it has the fixed IP for each block. In VLSM, we do the opposite of that. We calculate the subnet mask according to host required. I'm going to use this series for that, this topology for that. Suppose I have maybe in different city, I have 3 offices, like it's in Delhi, it's in Mumbai, it is in Calcutta. Thing is very poor, na? Done. Okay, leave it. Or maybe in same city, in different 3 locations. So naturally, to connect here to here, we require 2 IP. To connect these 2 sites, we require 2 IP. To connect these sites, we require 2 IP. Here we require 2 IP. Here we have 14 valid IP requirement. I just cleared up everything. Here we require 14 valid IP at this site. Here we require 30 valid IP for this site. Here we require 60 IP for this site. Okay? And 2 IP on this link, point-to-point link. This 2 IP for here point-to-point link and 2 IP for here point-to-point link. So keep it in mind. So when we do the VLSM, always start from minimum IP requirement. 2 IP, 2 IP, 2 IP. Means we require 3 blocks of 2 valid IP only. Valid IP I'm talking. I'm not talking about total IP. Here we require 14 valid IP. Here we require 30 valid IP, and here we require 60 valid IP. Maybe some condition we have one more branch, we require 120 IP. Suppose, let's see. Now keep in mind, we are going back to one formula where we calculate the host. How many total IP and how many valid IP, we have discussed earlier that. So in VLSM we need to consider the host bit required to fulfill the host requirement. In subnetting we are considering how many subnet we require. 2 raised to power y formula. Here we require to just opposite of that of subnetting. Here we have to take care for the host bit. How many host bit we require? Remain give to the network. In case of subnetting, we are borrowing the bit from host to network side. Now we are giving the bit from host to network side. I know it is little confusing, but very soon when we do it practically, we calculate, it will be creative. In subnetting, we consider how many bits to borrow from host to network side. But in VLSM, we consider how many host bit we require to fulfill the host requirement. Just opposite to that. Keep only that much bit for the host. Remain all host bit give to the network. Formula to be used is same that we used previously to calculate total and valid IP. 2 raised to power x total IP, 2 raised to what is x? Number of 0 in a subnet mask. 2 raised to power x minus 2 is the valid IP. What we have done the subnetting, just opposite to that. Process is same. Only to calculate the subnet mask process is different. After that the process is same to calculate the valid IP and total IP and network ID and broadcast IP. Come to this. In a VLSM, start from minimum to maximum, that I already explained you. So in the topology shown, we need 3 subnets of 2 valid IP. There should be only 2 valid IP. So remember the formula total IP, 2 raised to power x equal to should be 2. And valid IP 2 raised to power x minus 2 is the valid IP. So if we have 2 host bit, we have in this subnet mask, if we have only 2 host bit, okay, my requirement is fulfilled. In subnetting case, again I am revising, we are borrowing the bit from this side for network from host. Now we require only 2 host bit to fulfill this requirement. So what I do, I just keep 2 host bit. Remember I said I don't need, give it to the network. I'm not borrowing, I'm giving now. Now I'm giving, not borrowing. In that case, network has to borrow the bit from host. Now host is giving the bit to network. I don't need it, you take it. New subnet mask. This one. 255, 255, 255, 252. The main process is same. Calculate the block size with the interesting 256 minus 252. Like this. Block size will be 4. So look here. One block. First let me complete display. Look. 1 block, 2 block, 3 block and 4 block. So what we do, for any reason, for security reason, it will be easy for the hackers to detect or to calculate this one, can be any other reason. I am ignoring this first octet. It is recommended always ignore the first octet that you create in VLSM or subnetting also. So look here, 427, 4 IP, network ID, broadcast IP and 5 and 6 we can configure on 2 devices on that topology that I have shown to you. Just do one thing. 9 and 10, here 13 and 14 network ID, broadcast IP, valid IP 13, 14, 9, 10 valid IP, 8 and 11 broadcast IP, 5 and 6 valid IP, 4 and 7 is the network and broadcast IP. Come back in that topology. So 2 IP of same series we can configure on this link, 2 IP on this link when we configure the router or any device, or 2 IP here when we configure the link. Okay, so next requirement is the 14 IP. It is going very lengthy, I think. So 2 requirement has been done. Next, 14 valid API required. 2 raised to power 4 means we require 4 host bit only. Just opposite to the subnetting. I keep 4 host bit with me and give another 4 bit to the network. So the new subnet mask 240, same block size we calculate, block size of 16, zero network ID, 15 broadcast IP, 1 to 14, 14 valid IP. So again, I'm in this VLSM also, I'm ignoring first block. 17 to 30 I will configure on the 14 IP series. But subnet mask should be same that we calculated here, not the precision. With this IP series, you hardly have to mention 240. You hardly have to mention, each block will have its own subnet mask. If you do something wrong, everything will be messed up. So take extreme care when you are configuring an IP with the subnet mask. Each block have its own subnet mask. It's not VLSM that you have to use the same subnet mask with each block. Next requirement is 30. I have shown in the topology. Same process. 5 bit host bit we require. So 5 host bit means I have to keep 5 host bit and remain I will give to the network side. So here the subnet mask will be 224. So 256 minus 224, 32 in each block. Look here. Ignore first one. We already have used that IP also. And 33 to 64, 62. This is the network ID, broadcast IP and valid IP. Simple. Only you have to take care for how many host bit we require. In subnetting we have to take care how many network we have to borrow. Only this is the difference between subnetting and VLSM. Remain process is same. So done third requirement also. Come to the fourth requirement of 64. 60 valid IP according to topology. So 2 raised to power 6 means we require 6 host bit, give 2 bit to the network side. Subnet mask is this one. Interesting octet 256 minus interesting octet. I have repeated many times interesting octet where change take place. So block size is 64. You can see very clearly. Already IP has been used, or I'm not using that. Look, exact 62 IP we get. Network ID and broadcast IP. But again, you have to mention the subnet mask, this one. .192. So you can configure this IP series with this subnet mask where we require the 60 valid IP. So this is the VLSM. Hope everything is clear to you now. Okay, we have discussed so many things, complete structure, classes, and everything we have done. We have done subnetting, VLSM, CIDR. I just want to make you more. One topic I want to add here. Like we are doing the subnetting or VLSM, whatever we are doing. We have calculated this new subnet mask. We have calculated this subnet mask with this IP series. Default subnet mask is this. So either we can represent the subnet mask like this, or what we can do, we can write it like this also, 8. Normally if anybody works on router, so router always represent IP with subnet mask like this. Some more. Next example here. Okay, so now our new subnet mask is this one. Either we can, by default, this is a default subnet mask, so we can mention it. Sorry, you have done wrong. How we can do it? We can write it here /24. Network bit I have to show here. By mistake I have shown either host bit, but here 8, 8, 8, 24. So you can mention it like 24. But when we have done this, when we have done the subnetting or VLSM with the new subnet mask, it becomes /28 representation. Purpose of this slash is to show the subnet mask. By writing the slash with the IP, writing a particular number, we are showing the how many network bit we have. So here we have the 888 24 bit, but after doing the subnetting or VLSM, 4 bit also goes to network side, so now it becomes /28. Just /28. Okay, initially it was /24. So /24 representing me how many network bits are there in a subnet mask. Come next. Done. Next example, wait. I want to show you some more, like 16. Like here, default is /24 because default subnet mask is 888 24. And now in the new subnet mask we have added 2 more bits in the subnet mask to the network side, so it becomes /26 now. It is known as a CIDR representation or CIDR notation. Classless inter domain routing, CIDR. now classless inter domain routing. This is CIDR notation to represent a subnet mask. How many network bit we have in the subnet mask? Purpose is same. To use a subnet mask, purpose is same, just the representation of the network bit. Okay. So we have done everything here till yet, as much as we can do. Remain depend on your practice. How much practice you do, how much you become perfect in it. So in this way, we can design different subnet according to the requirement without the wastage of IP. Every block has its own subnet mask. So when we are configuring the IP of different blocks, we have to take extreme care for the subnet mask configuration too, as well as IP. Okay. So in the IP series video, it is our last but not least to discuss about private and public IP address. Okay. Till that we have done the VLSM. Now we will discuss about private and public IP. Basically, IP have 5 classes and 2 types. Not 2, 3 types. One is the private IP series and one is the public IP series. We will discuss one by one what is public IP and what is private IP. A public IP address is a unique address assigned to your network router by your internet service provider and can be accessed directly over the internet. Yes. Whenever you take any internet connection, it means you are taking a public IP that is given by the ISP. That is globally unique IP. That is globally unique IP. And private IP is a unique address that your network router assigned to your device. We have done the subnetting, we have done the VLSM. You configure that IP series on your router or any DHCP server that will, or you can statically do that inside your network. But with the help of these IPs, you cannot go into the internet. To go to the internet, you require a public IP that is assigned by the internet provider. Private IP, you do the subnetting, you do the VLSM and assign them either statically or dynamically with the help of DHCP. But you cannot go outside with the private IP series. I will show you which is a private IP series and what is a public IP series. It is used within a private network to connect securely to another device in the same network. Private IP only for the internal communication, cannot go outside your network. And public IP assigned by the internet service provider to access the internet. Okay, let's discuss more. Public IP. A public IP address is an address that is provided by the ISP from where taking the internet connection. On the internet, it recognizes your device. The internet is accessed through your router public IP address. So it must to have one public IP address from your ISP to access the internet. So that is also theory, nothing so complicated. Just to make it more clear, public IP addresses are commonly used by the publicly accessible enterprise such as websites, DNS, VPN servers, because they can be accessed from anywhere in the world. You can not go online without having a public IP address which identify your device on the internet. Your router is an intermediate between your computer and the internet on a typical home network. Like if you take the internet connection at your home, in that case also whatever the router or modem the SP will provide you will have one public IP, and from there you can connect to your internal device using your private IPs. Private is a local IP. Leave the theory written here. Just one word, it is non-routable. Okay, it is non-routable means it can be not be route over the internet. If you're not connected to internet, you can use any IP series to communicate within the network. But if you want to go to internet, any open web service, then you must have to have a public IP. So private IP is non-routable, means cannot go over the internet, cannot be routed into the different networks, cannot go into the different networks. But suppose you have devices, you have connected machines here, can be mobile, can be your laptop, can be your desktop, can be anything. With the help of just a minute, let me draw it. This is your cloud. This is your internal network. You can communicate here. You can communicate here with the help of private IP. But if you need to go to internet, then you must have one public IP. You must have to have one public IP. Okay. So this is the private and public IP range. Private IP range, sorry. Private IP series. In A class, 10.0.0.0 to 10.255.255.255 is the A class IP in private. In B class, 172.16.0.0 to 172.31.255 to 255 is the B class private IP series. And in C class, 192.168.0.0 to 192.168.255.250 as a private IPs. You can use these IPs in your private network without any permission. But apart from these IP series, if you have to use, you start using 11, 12. If you are not connected to internet, then no problem. But if you need to connect to internet, you cannot these IP series in your private network, except these IP series 10, 172 and 192. You don't require any permission. But apart from this, if you need to use any IP series, then you need to take the permission or take the internet connection. Then ISP will provide you a unique public IP. Okay. And last thing that I want to discuss, that is the APIPA, Automatic Private IP Assignment. Suppose you have configured the IP via DHCP and your client machine not able to reach up to the DHCP, or your DHCP server is down, then automatically one of the IP get assigned to that machine. When DHCP client computer connect to the network, it attempt to communicate with the DHCP server. I hope you know about the DHCP server, Dynamic Host Configuration Protocol, where you configure a IP series or block or subnet on that. So it automatically assigns the IP to the other machines in the network from that series. If a server is available, then it will assign the IP address and other network parameters to the DHCP client. In some cases, a DHCP server may be not be available, down temporarily, or there is no DHCP server. In that case, if this occur, then APIPA is enabled. APIPA is enabled. Automatic private IP assignment. A client computer select an IP address from this range. This is the APIPA range. Keep it in mind. This is the APIPA range. 169.254.0.0, 169.254.255.255, and automatically that address to itself. Okay, so APIPA is in case your DHCP is down and not able to connect to the DHCP server. In that case, from this IP, your machine will choose any IP or assign to itself. The Internet Assigned Number Authority INA reserve these addresses specifically for APIPA use case to ensure they don't conflict with the DHCP routable address. So you cannot configure these IP manually or via DHCP to any machine. These are the reserve series again. As private IP is reserved, this IP series is also reserved. Okay, so this is the APIPA like this. So if DHCP client trying to discover DHCP server, but DHCP server is not available, then it automatically assign one IP from this series. This is the APIPA. So I think we have done a lot here. Everything about IP. Thank you. Hope you learn and enjoy the video. If any doubt, please write me to comment, and be sure to do a lot of practice for decimal to binary, binary to decimal, then block calculations and everything. And after this, if you done it well, repeat it again and again. If you done it well, you need not to see any other video on the YouTube or anywhere, and don't get any confusion here. So thank you very much. Hope you enjoy this video.